Hello everyone and welcome to another video here on the Polaris School of Quantum from the Hidden Quantum Champion series. Today we are going to look at Maybell Quantum, and without further ado, let's hop right into their website. So here we are on the website of Maybell Quantum. It says the Quantum Infrastructure Company, and we can already see those black shelves here looking like a closet. Summed up in a row, and I guess we will learn in a second what this is actually referring to and what this is about, but we can already see it scales, so there's a lot of them. Looking down here, it says Maybell builds dilution refrigerators that are intuitive, reliable, and obsessively engineered to meet the growing demands of the quantum industry. Explore products, and then dilution refrigerators. And I think if you've watched already the previous episodes of this series, you might already know some other companies that are in this market. So the dilution refrigerators, just for the people that haven't watched the previous episodes, are a fundamental element of, let's say, the solid state quantum compute systems, referring to spin qubit systems, but also superconducting systems like flux qubit and other Josephson junction qubit based systems. So they are at the very core of this, and you know them probably from the images because they look like these chandeliers, and you usually have the signal lines going down and the quantum chip sitting at the bottom of them. Now, dilution refrigerators, the fast fridge, quick turnaround, fast characterization. The fast fridge is affordable, flexible, and quick, so you can iterate faster and get from idea to impact faster. Explore the fast fridge, and that's the system here. Then we have the fridge, the original quantum workhorse built to last. The fridge offers 360 degrees access and proven reliability with a footprint compact enough for almost any lab. Then there's the Fridge Plus, upgrade your lab with premium performance. The Fridge Plus offers everything you love about the fridge, plus faster sample swaps and 4 times more sample capacity. And now this is a very important feature for research. So in research, usually you want to be able to switch or swap the samples within your systems, and there are different types of systems. So there are some systems which you have to warm up. So you go from from the millikelvin temperature in the cold stage, which is minus 273 degrees Celsius, all the way up again to room temperature, 20 degrees Celsius. You change the sample, and then you have to do the cool down again, which takes, depending on the system, 1 to 2 days or maybe even more. And of course, a lot of energy. And there are other systems where you can actually, let's say, drive the system up into a slightly elevated temperature stage, like, I don't know, 4 Kelvin or something. And then you can actually exchange the sample while keeping the fridge at this low temperature using additional stuff, like, for example, a turbomolecular pump, a special sample exchange system, and so on. But you can do that while keeping the fridge cold. And that's then, of course, much faster because you only have to cool it down again from, I don't know, 70 Kelvin or 50 Kelvin, whatever, because when you take the room temperature sample and you mount it to the cold stage, of course, it needs to reach a thermal equilibrium again, so it will not be at 4 Kelvin right away, but it will warm up a little bit, and then you cool down. But overall, the thermal mass that you have to cool down, including, for example, also the superconducting magnet that might sit in your fridge, is much, much smaller, so you can go much faster in cooling it down. So that's a very important element, at least for these academic setups, which you have in the lab. And then it says here 4 times more sample capacity. I think that is relevant when it comes to, for example, also quantum computers, where, let's say, the amount of lines, signal lines that you need to carry down to your sample, and then also the sample size by that, is getting bigger as more and more qubits are finding their way down into the systems. And then here finally there's, I guess, no, not finally, but then here there's the big fridge. So scale up your quantum research. The big fridge offers twice the power, twice the wire capacity, and 5 times more sample capacity for labs that demand scale. So here you see it, twice the cooling power, which is then important if your chip is getting bigger, and most notably as the number of wires increases. So here twice the wire capacity, so you can have 2 times as much signal lines, radio frequency and DC, I guess, that are going down, and then 5 times more sample capacity as probably in sample volume down there. So dilution refrigerators, you see them here. Decide which system is right for you. Maybell builds beautiful performant dilution refrigerators, obsessively designed to support more qubits in smaller footprint. And I really like that they have a very specific design. So if you see one of those systems in the lab, I guess you know exactly where this is coming from. Now looking at it with my cryogenic eye, I would say, I guess there's like there are different components which are housed inside these units here. So I guess this is like the pumping rack back here with the compressor and the turbomolecular pumps and so on that you might also put in the next door's room. Then you see here, I think there's like the pulse tubes connected up here. So there's probably the cooling unit sitting, or the cold unit, the chandelier sitting in there. And then you also usually need some space for the computer, the thermometer, and also the helium gas tank where the helium mixture, so the dilution mixture goes in. And that's probably also sitting somewhere there. But we will probably see more about that as we go throughout the website. Then decide which system is the right for you. Maybe, yeah, we've seen that already before. There's a quiz to learn which system you actually want to have. And I guess if you are a lab, I encourage you to check it out. This is probably a fun way to figure out which system you want to have. So quickly clicking on that. Yeah, so it's really like typical questions. I want to have 30 millikelvin, number of radio frequency lines, magnet, sample size, and so on. And then, okay, you get, you put your information here, and then you get the quiz result from the Maybell team. They are so nice to share how well you performed in that quiz. And maybe they also sent you an offer or invite for a phone call. Wiring solutions, flexible, scalable wiring for every system. Our universally compatible wiring offers a low thermal load in more compact footprint. And that's also very important if you're targeting academia. So for, let's say, the typical superconducting quantum computing system, you know pretty precisely what type of lines you need to have down there. But if you want to do various types of experiments, you need different wire setups. You might need more DC lines, more radio frequency lines. You might need a magnet or other accessories. Sometimes you also need, I don't know, specific shielding, as it says here. So maybe if you have something that is very, very sensitive to magnetic fields, like a squid sensor, you might want to have a shielding that shields off magnetic fields. There might be some thermal shielding. There's also some cases where you want to have radioactive shielding, because if you, for example, and that's, I think, some research that MIT has been doing, if you are running a quantum chip, a quantum computing chip, then actually cosmical particles that are coming, for example, from the sun, muons, they can hit the chip and they can actually create an error within your chip. So what the MIT actually figured out in some experiments, and I will not link you the paper, but I encourage you to look up for it if you are interested in that. What they did is they put their system down in the basement, and I think they put some LED shielding around. And then they saw that, okay, the error rate in that system actually decreased. And they also could see that, I think, sending radioactive radiation on the system, they could see that the error is actually spreading due to this impact of the particle, radioactive particle, onto the chip while they were running their calculations. And again, because it's a quantum system and you have entanglement throughout the system, if you are creating an error due to a particle hitting in one space, that will spread over your whole system. That's why eventually you will need this error correction, and mitigation schemes alone and the high fidelity alone might not be enough to solve this problem. But that's a different story. I'm drifting away from today's topic. We were looking at Maybell and the fridge systems they have. So here it says Maybell Quantum closed a $40 million Series B led by Addition. Maybell Quantum, the quantum infrastructure company, today announced a $40 million Series B financing round led by Addition. The investment will accelerate Maybell's commercialization of next-generation cryogenic and RF systems, critical infrastructure for enabling the quantum future. That was on September 3rd, 2025. I'm recording this mid of November 2025, so then you already know that this is pretty much actual, pretty much state-of-the-art information. There's some more down here. So for example, end of October, Maybell Quantum salutes Elevate Quantum's EDA Tech Hub designation. So Colorado is set to solidify its role as a global epicenter for quantum innovation as the US Department of Commerce designates Elevate Quantum a regional technology hub. And there's more news down there. So then the latest Maybell news, obsessively designed and tested. Oh, that's what we've seen already. Unmatched reliability, no scroll pumps, no solder joints or acid flux, no indium or epoxy, 90% reduction in rubber gaskets, and self-rearranging helium traps for maximum uptime. Regenerating. So what is that? Scroll pumps is a specific type of vacuum pump. I'm not going into the details of that. Solder joints, of course, when you're looking at these fridges here, where you have super cold temperatures and vacuum, solder joints are not ideal because first of all, you might have vibration in the system. Everything is extremely cold, so extremely rigid. And then solder joints are not, let's say, ideal. They can easily break, and especially because they're also supposed to carry electrical signals. That's not ideal, right? And I have to say also oftentimes in the research labs, solder joints are also misused for cables, also to create, let's say, a physical stability where you should rather use a plug. And then, of course, when you cool it down, almost every time something breaks and then you have to resolder it. Then, of course, depending on what type of solder junction you have, there's also flux, which kind of leaks into your vacuum because when you are cooling down the system, all the gas which is still in the system, of course you pump with a turbomolecular pump on it to reduce the pressure within the system, but there's always gas left. You can never remove anything. But then when you hit the cold temperature, it will start to freeze. So the rest gas will be attached basically to the cryostat because it's so cold that it will just liquefy or even solidify these gas particles that are left over. And then, of course, if you, for example, have acid flux, this flux will not be cleaned off perfectly and then it will still evaporate and you will have this evaporation, so this heat transfer somehow happening within your system, which is not ideal. Then indium is a material that is pretty rare and that is used very preferentially, especially in older cryostat setups, to create vacuum tight and also cold temperature stable sealing. But of course, as this is a very rare material, it is kind of problematic because you always have to kind of, once you use the sealing, you scrape off the indium and you basically send that for reuse, or you actually do reuse it just by yourself for the next sealing. So this is not ideal. Epoxy is also not necessarily a material that you want to use in a long-term production state type of setup, right? Then it says 90% reduction in rubber gaskets, again, because they are also a maintenance point in those systems. And then the self-regenerating helium traps, again, I told you also in previous cryostat episodes here of the Hidden Champions that this is something which you are still manually refilling today with liquid nitrogen, these traps. And then, of course, if you have a regenerating one, that might also lead to less maintenance work on those systems. Then it says user-centric design, front opening access, integrated workspace, and intuitive controls that let you focus on science, not babysitting your fridge. And I can tell you that's something that every scientist like to hear, because there's actually quite a lot of work involved in keeping those fridges up and running, making sure that they are functioning well, and you probably every place that has a lot of these systems, they also have at least one expert who is really like, whose not only job, but whose main job it is to keep these systems up and running and make sure that if one is going down, this thing is coming up again quickly. So you always need an expert with the fridges. And now it would be very nice to have babysitting free fridges in your lab. Then it says superior performance, consistently achieving base temperatures below 10 millikelvin with the quietest experimental environment in the industry. So that is also a very interesting point. So first of all, these 10 millikelvin achievement would be very great, because not always you reach actually the perfect base temperature. So it would be cool if every time you would do it, you would actually even reach it. And then of course this quietness is another point, because today we have these pulse tube coolers which are pretty loud. You have a compressor, you have different types of pumps that are sitting, and usually when you have those setups, you basically separate the pumps and all of the requiring auxiliary instruments. You separate them into another room because they are so loud that you cannot work next to them properly. Then it says expert support, 3-year comprehensive warranty with same-day response and a dedicated team of specialists who help design your system. And then American made and manufactured in Denver, Colorado, with rigorous quality control and testing. Okay, and that also means we already know where they're based, which is in Denver. Let's quickly scroll up again and check out the product. So we've seen it already, the fast fridge. Here's a nice video. I guess it's an animation video, like a cat video of what the product looks like. Here are the key selling factors. So lowest cost, maximize your research budget with the most affordable path to millikelvin temperatures without compromising performance. Low acquisition cost than competing dilution refrigerators, and I guess that has something to do with the way that these are manufactured. Reduced infrastructure requirements with compact footprint and integrated systems, for example, no liquid nitrogen. Minimal maintenance cost with self-regenerating traps and maintenance-free pumps. That's also what I mentioned before. And then energy-efficient design that cuts electricity consumption and cooling water requirement. That's also something which I didn't mention before. So for example, for this compressor, the helium compressor, and sometimes also for the turbomolecular pump, you even need to have a cooling water, so a cooling water circle connected to the system, which is definitely also a special requirement that not everyone can fulfill. Then maximum flexibility, adapt quickly to changing research properties with a system designed for versatility and rapid configuration, configurable between 30 millikelvin or 10 millikelvin base temperature and custom shielding. Quick swap via loaders allow experiments to be prepared in parallel and swapped in minutes. And then upgradable design lets you use the same wire tree for the fridge plus or big fridge with no modifications. Fastest cooldown. The fast fridge is purpose-built for high throughput experimentation and rapid characterization, all with minimal downtime, so 24-hour turnaround from room temperature to base temperature and back. Streamline thermal path with reduced thermal mass for maximum efficiency, and then automated cooldown sequence with state-based triggers so that every sample is cooled as quickly as possible. And here we see the system again. Another interesting thing that you could see, and it was mentioned before, you have this door here in front here with the handle on it, and you can actually open that and you can access the fridge like this inside. So you don't have to remove, as today, shields by basically peeling it like an onion step by step, moving those shields down one by one, but really you can just open a door and you are basically reaching into the cryostat right away, of course as soon as it's warmed up to room temperature. So yeah, that's the system. Here is some more information, just very quickly, because that's also something that people tend to not know, and that is kind of a surprising fact. So the cooling power at the lowest stage, so here at the 20 millikelvin, or well, the lowest stage is the base temperature stage, but at the millikelvin stage here, 20 millikelvin, is usually in the microwatts range, so 14 microwatts. That means if you apply 1 watt down there, so a resistor with if you apply 1 watt, or if you take, for example, your LED down in there, it will already explode the system, right? It will create more heat than what can actually be carried away. So you really need to have this, that's not a problem because the quantum chips are anyways operated at these super, super tiny voltages. But of course, the main heat load comes from all of the cables that are going down and transferring heat down. But this is to be compared with these 14 or 16 milliwatts or 14 milliwatts, microwatts of cooling power. Those have to be compared with the kilowatts of power, electrical power, that actually go into the compressor for cooling down the first stages. So you take kilowatts of power that you're pumping into the system to reach microwatts on these super cold stages. So just to show how complex it actually is to reach those low temperatures and how many processes are sitting in between there, right? So obsessively designed and tested, unmatched reliability, and I think we've seen this already before on the main page, and this as well. Now that I think is the fast fridge product. There are also other products like the fridge, which I think is the main line product here. That's also, I think, similar to what we've seen before. So more than 3 years on the market with a proven track record of outstanding performance, no solder joints or acid flux to degrade over time and cause leaks. Here you can, by the way, also see the system. Again, you have this handle opening, right, and you're reaching right into the cryostat. Maintenance-free micro root blowers replace failure-prone scroll pumps, then metal to metal and welded connections instead of rubber O-rings, indium, soft solder and epoxy. Self-regenerating helium traps that never require manual refilling. That's also something that we've seen before and I mentioned. And then industry-leading service and support backing our confidence in system reliability. Then there's the 360 degrees access. Enjoy a revolutionary design that transforms how researchers interact with dilution refrigerators. Open door sample access, provide unprecedented access to your experimental setup. Integrated chamber lift for full system disassembly and easy sample preparation and manipulation. Parallel front loading wiring inserts allow complete wiring assemblies to be prepared outside the fridge, and then all around accessibility eliminates blind spots and provides a similar experience to traditional systems. And then compact footprint, we've seen that utilizes only 10 to 20% of the floor space required by comparable system. No overhead superstructure required. That's also something that you might have seen with the other cryostats. Sometimes you have these aluminum structures, these aluminum profiles that are being used to actually expand the structure into the air, which is needed because the fridge itself is hanging on a structure, and then you actually have to provide this system which you suspended it with by yourself. And that's also something that here apparently comes with the system. Then it says it fits within two standard 19-inch racks with 9U of space for electronics, and then reduce infrastructure requirements for cooling, water, electricity, and HVAC. So that's, let's say, the standard fridge product that they have. And then there is also more. You see there's like wiring solutions and magnets and accessories that I've also mentioned before. So there are different types of accessories that you can get. There's also the Make You Labs tab up here. So lowering the barrier to entry for quantum computing research. Here we see now lab. It's called Make You Labs, offer cutting-edge quantum hardware at the fraction of the cost. Whether you're a startup working on your first qubit or an established business looking to test and characterize products, Make You Labs offer the flexibility you need with expert service, scalable capacity, and cutting-edge hardware. So you can reserve a space in their lab. It's a cost-effective way to run experiments without investing in hardware. Cryogenic capabilities, control electronics and RF wiring and components. Scalable capacity lets you reserve more space as you grow. Full-time quantum engineers available for on-site support. Design for startups, large enterprises and research labs. And then lab space now available in Denver, Colorado and Copenhagen in Denmark. So they have both in the US and in Europe one of those labs, which you can actually use to do your experiments. And here you see the different systems. So there's this super big one, the huge system, and then also the standard systems over here. I'd be interested, of course, also in knowing what type of measurement electronics they have and which one can be used, or if you're also expected to bring your own stuff, what type of filters you can actually get for the signal lines. But of course, I guess if anybody's interested, you can always, let's say, reserve space, reach out to them, and then they will probably tell you what they have and what you are expected to bring. As always, we also want to quickly check out the About tab to learn a little bit more about the company. We are already knowing that they are based in the US. So here it says reimagining cryogenics for the quantum era. So they're building fridges for quantum technology. We founded Maybell in 2021 to build the cryogenic infrastructure that quantum technologies actually need. Our American-made systems are used by leading research institutions, national laboratories, and commercial quantum developers across 12 plus countries. We are backed by strategic venture partners and driven by the belief that quantum infrastructure must evolve in order to enable quantum scaling. And that's indeed something that we've seen here before, right? There's a focus on making these things cheap, reliable, easy to maintain, so that they can actually be used in production type of applications. And I guess that's the focus here, away from, let's say, the standard lab setup that has to be flexible, that is kind of hacked together and so on, towards something that is reliable and can be operated 24/7 with minimum downtime and so on. So built with scientists in mind, not just technical requirements, engineered to run for years with no maintenance at all, intuitive access and control that simplify complex work, compact footprints and modular systems that grow with you, backed by expert support and commitment to your success, and meticulously designed and manufactured in Denver, Colorado. Why Maybell? Reliability, built to run and run and run. Maybell fridges are designed for maximum uptime and reliability. Our team's decades of experience in designing, using, and servicing competing dilution refrigerators enabled us to identify the biggest causes of failure and eliminate them. Unlike traditional systems, there are no scroll pumps on the circulation line to maintain or replace. Our micro roots blowers run for years without service. There's no acid flux or solder in any of our joints that could degrade over time, and we've reduced the number of rubber gaskets by 90% compared with competitors. Connections in our system are welded or metal sealed to preclude leaks for decades. Even routine tasks like adding liquid nitrogen are a thing of the past. Our integrated cold traps regenerate automatically and never require liquid cryogens. The result is a cryostat that can stay cold for years with zero maintenance. We back this up with a robust warranty. In short, Maybell delivers unparalleled reliability, keeping your lab running smoothly week after week, month after month, and year after year. And here we see, I guess, the gas control system with the various switches and gaskets and the various connectors and tubes, and then what is being used to drive the different valves, and the stainless steel tubes for the vacuum in the handling. This is now the electrical setup. Right here you see the radio frequency lines being inserted. It says usability, focus on science, not on the fridge. Using a Maybell fridge is straightforward and stress-free, in stark contrast to many legacy systems. We've introduced features that users have long dreamed of: a front opening door for easy access, parallel front loading wiring modules that simplify experimental setup, rapid sample loaders that allow you to insert the full experimental setup from room temperature through your sample in minutes, not days. No other dilution refrigerator on the market offers these conveniences. Where competing systems require deep expertise and extended timelines to open, disassemble and change a sample or rewire, our systems can be turned around in minutes. And that's what you see here with this system, right? So he's loading all of the cables at the same time in there. Maybell empowers your team to do more science with less frustration. Young researchers get up to speed faster, and seasoned experts can push their experiments further without fighting the hardware. When comparing, ask, does this other system expect you to spend hours under or inside it? Do they force you to use proprietary software? Are they built with you in mind? Maybell's openness and user-centric design spark for themselves. And I would be very interested also in knowing, let's say, their openness in terms of what software they're actually using, but not sure if we will figure that out today. But if somebody of you is using them already, let me know down in the comments below. I'd be very interested. So no compromises at mil-Kelvin temperatures. Performance both about hitting the lowest temperatures and about maintaining excellent conditions under real experimental loads. Maybell systems excel here. Our fridges routinely achieve base temperature below 10 millikelvin and, more importantly, hold those temperatures stable for months with literally zero intervention. Thanks to our improved thermalization layout, you get more experimental capacity out of a nominal cooling power, for example 500 microwatts at 100 millikelvin, because you can intercept and dissipate more energy at higher stages. We cool more wires and bigger samples without sacrificing base temperature or stability. Our fridges also provide an exceptionally low noise environment. We've integrated superior vibration isolation, IR, so infrared absorption, and EM, electromagnetic shielding, to ensure that your qubit sees an ultra quiet background. In head-to-head comparison, Maybell fridges have the lowest measured vibration at mixing chamber and the lowest electromagnetic interference attributes that directly translate to better qubit coherence and experimental fidelity. And if you need high magnetic fields, our integrated magnet option deliver without compromising the cryostat. No quenching nightmares or awkward retrofits. In summary, Maybell gives you top-tier cryogenic performance on all fronts: temperature stability, noise, experimental capacity, and environmental flexibility. You don't have to trade one for another. And I mean, there's even more to come here. I don't want to go into all of this now. Just one quick comment on the quenching, because I think that has not been explained before. So if you have a superconducting magnet, there's a maximum current that you can actually run through it, because if you run a higher current, the current is producing a magnetic field that is breaking the superconductor, and then the superconductor turns into a normal conductor. So suddenly it has resistance again. And the energy that is being dissipated over a resistor is basically R times I squared, and I is the current. So if you have a pretty high current, even at a low resistor, you will have quite a lot of power dissipated. And that means that suddenly your magnet becomes a strong heater in your system. So it will immediately create a lot of heat. And that heat will then get the liquid helium that is being used for cooling from its liquid state to a gas state rapidly. So suddenly all of this is expanding. It's a little bit like an explosion. And for example, in the old helium cryostats, you would then see that like suddenly all of the valves are opening and you see a white cloud of freezingly cold helium shooting out of every opening of your cryostat. And of course, on the newer systems, you will have possibly breaks within your cooling units where then suddenly it's leaking somewhere, helium is going everywhere, and in there you have this mix of helium-4 and helium-3, so a lot of money is immediately evaporated, literally. So you don't want to have that, and that's why this is being mentioned here. And I think a quench is really a nightmare that nobody wants to see in a cryostat. Then there's also something about the scalability, the service and support here. And finally, join the team. We are a team of scientists, engineers, and innovators. Check out our current openings if you love deep technical challenges and are passionate about building the next generation of quantum infrastructure. And then again, we come here to the news, as we've seen before. That was a little overview about what Maybell is actually doing, the quantum infrastructure company. I hope you liked it. If so, please again, make sure to leave this video a like. If you don't want to miss out on the next one, make sure to subscribe. If you have some more time, check out the Quantum Hidden Champions playlist. And with that, I'm closing today's video with a little sip on my water to hydrate myself again, and look forward to see you in the next one. Bye bye.